In this paragraph, in first question, we are giving two functions fx and gx, and we are supposed to comment on the monotonicity of gx. That means where gx is increasing or decreasing. For that we require sine of g dash x, so I'll differentiate. If you are differentiating this expression, differentiate x, that will give you 1 into, in place of t you will put x, that will give me twice of x minus 1 upon x plus 1 minus ln x into f of x. So this is my g dash x. Wherever this would be positive, the function gx will be increasing, and wherever this will be negative, the function gx will be decreasing. Now you can see fx is having a square, and a square, so this cannot change its sign. That means this quantity is surely positive, or rather non-negative. Now to find sine of g dash x, I am supposed to know whether this is greater than this or vice versa. Now we know the graph of ln x. X minus 1 upon x plus 1 will be a rectangular hyperbola, and if we are plotting the graphs, the graph will look like this. The graph of ln x will be simply this. This is y-axis, origin, x-axis, and the graph of other function, that is x minus 1 upon x plus 1. If I am putting 1 in place of x, this would become 0. That means its graph will pass through this point. If I am putting x is equals to 0 over here, the entire value will be minus 2. That means it will pass somewhere from here, and as it is rectangular hyperbola, it will look like this, right? Something like this. Now I can see after 1, the ln x graph is always above the graph of this rectangular hyperbola, so this is always greater than this quantity. That would give me g dash x as negative, because this is always positive or 0. This will imply for x greater than 1, gx will be a decreasing function. Again, second part of the problem says he is giving two statement, that is px is fx plus 2x is equal to twice of 1 plus x square, and in p he states there exists some x which is a real number which satisfy this. Similarly in q he states that there exists some x which is a real number which satisfy this. Now let me examine first of all p. P is fx plus 2x equals to 2 plus 2x square. If I am substituting fx, I'll get something like this. Finally, after calculation, that is x minus 1 whole square plus 1. After calculation, it will give me sine square x equals to 1 plus 1 over x minus 1 whole square. Now you can see, whatever be the value of x, in 1 we are always adding something which cannot be even 0. It has to be positive, so this is always greater than 1. But because we know sin square x cannot be greater than 1, so statement P is false. There is no solution to this. Similarly, if we are examining Q, that is 2fx plus 1 equals to 2x into 1 plus x. In the question we are provided with fx. If I am substituting that value, finally I'll get something like 2 sine square x into x minus 1 whole square is equals to 2x minus 1. And that would give me sine square x, 2 sine square x equals to 2x minus 1 plus 1 over x minus 1 whole square. Now this is fairly simple. If I simply observe that if x is approaching towards infinity, your right hand side, because of this and this which is present in denominator, it will approach towards 0. Now if x is approaching towards infinity, this 2 sin square x will keep on fluctuating between 0 and 2. That means the graph of this function and the graph of this function will intersect. That means this equation will have at least one solution. So for sum x, definitely LHS and RHS could be equal, because right hand side lies in the range of this expression. So Q is true, and that's our answer.